today we will share about Presto plus Lance, how to unleashing advanced SQL capability for AI-driven data workloads. I have my co-speaker, Beinan is here. Beinan is an infra engineer and is also the Presto committer and Presto TSC. Beinan, why don't you just show your face to everybody? Okay. And I'm Lu, so I'm the database engineer from LanceDB. So today we have two main topics. We will first go through the AI data lake, and then Beinan will share his latest development of Presto plus Lance connector. So we face several challenges when we talk about AI data lake. The first one is when we're facing the multimodal data. Previously, the tabular data is really small. It counts like 145 bytes per row. But when we come to embeddings, when we try to generate more numerical representation of the task information, the embeddings normally takes around 4 kilobytes. It's 25 times larger. And later on, we also have images and videos, which is much larger than the tabular data. And the training data set also get much larger, from Cypher around 163 megabytes to ImageNet around 150 gigabytes, to some task-only large language model, which is around 10 terabytes, to image and video foundational model, usually takes around petabytes. And currently, the largest Lance data set is around 10 petabytes. So basically, the training data set are scaled at several magnitude larger, every several years. And the challenge 3 is that we face diverse AI workloads, from analytics to training to exploration to curation to evaluation. So we kind of bring down all the things into this new CAS theorem. So in the AI workloads, we want to search and filter to get the information that we want. And this requires us to do fast scan the data set and quickly get the information that we want. And when we get the information that we want to quickly shift it to the training workloads in the order that we want. So we require some shuffling. In order to have good performance, shuffling requires us to be more random. So different GPUs see different data set in different epoch, which require random access. And for filter to have good performance, random access can help us to quickly identify the information that we want and quickly locate those information and fetch it from the data set. And lastly, training, we are not just working with small tabular data or even embeddings. Many of times, we need to stream in the original data set, the images and videos, all the way to the GPU nodes. So this requires us to do fast streaming of large blocks, which normally resides on the object storage. The reason that we call it the new CAS theorem is because the old one normally cannot be solved. But we think that the new one can be solved. Well, what if we can solve all these 3 problems in once, given that we have a joint open source communities from both Lance and Presto? We have the shared vision to bridge big data and AI to create the AI data lake. We have the Pandas co-author, the SPNC of Hadoop, and multiple PNC from Apache Arrow project, and Presto committers, Presto TSC, and other PNC and committer from a bunch of big data and AI frameworks. So basically, we can say that if you somehow touch big data in the past decade, you may use likely that you use the products that we built. And the foundation for this AI data lake is called Lance format. Lance format is a modern columnar format for AI. If you guys familiar with something like Parquet, it's the next generation that we solve all the previous challenges in this new AI column format. And the one difference is that it supports multimodal data, all the way from embeddings to images to videos. You can put some really small data together with large blobs, all in one data set. We have version manifest to support time travel, zero-copy schema revolution, and one special thing is we also put indexes inside this Lance format. All the vector index, Scala index, full text index are all reside with the data itself. So it's not bounded by the memory limitation. You can put them in the objects in the cloud storage. Because of this design, we are able to support millions of tables and trillions of rows per table. Remember Cassian that we want to support different workload at a really good performance. So the data access, we have fast random access. We are 1,000 times faster than Parquet. We provide comparable scan performance to Parquet. And we support all bunch of different search and filter, like SQL search, similarity search, and full text search. If you are curious about how we actually implement it and what design decision that we have made and for what reason, feel free to look at our source code in the GitHub. And also we have a bunch of blogs from the Apache Arrow PNC Weston. He shared a bunch of thoughts about every detail that we did, how we designed this Lance format. One special thing here about this format and this AI data lake is that your AI data lake is your vector database. So most of the vector database these days store all the vectors in memory, so that if you want to scale it up, you cannot scale compute or storage separately. You have to scale them together. And memory is a hard limit for how much vector you can actually store. But in Lance format, the indexes are linked with the data, and the vector index is this space. We put all the indexes in the cloud storage, so your compute and storage is actually separated. You can scale up the compute or scale down the compute to even down to 0 when you have more queries or less queries. And we also have Scala index for filter pushdown. So I think Beinan can talk more about this for later. So we have the Scala index, so all the Presto workload, Spark workload, they can do efficient filter pushdown. And all those things are only made sense when you support random access, because we need to quickly use all the indexes to locate to the information that we want. And we want to quickly know that, okay, this information is stored in this buffer from which offset to which offset, and quickly get those information out from the data set. And those are only supported when you support random access. And one easy thing to try out to launch your compute. So previously, we talked other thing about the Lance format, which is the storage part. And the compute part, one example is that we have an open source embedded vector database. It's a pretty lightweight vector database that built on top of Rust. And it's just a Python library. We also have the Rust library. You can directly do import LanceDB and import pandas or PyArrow. You can create a table from your existing pandas or PyArrow dataset. And then you create the index that you want. For example, you can directly create the vector index. And after which, you can use table.search, put in your query. It can be an embedding, or it can be a wording query like, okay, I want to search who is the, anybody here that's most likely to try out Lance after this conference? And I can also do a bunch of filter. So it's not just a similarity search. I can also filter on the information that I actually want. Like here, the price need to be bigger than 10, and pre-filter equal to true. So this LanceDB is actually not just used for vector database. Many of the people have built many things on top of it, like continue basically the code completion AI tool and multiple AI agents. They leverage LanceDB and Lance to build their application. And we also have the cloud offering, which is a distributed vector database. Basically, we launched the open source embedded vector database, LanceDB, in our query nodes. And we just launched as many as basically the query needs. And this one, every component can be independently scaling. And we have the cachery, we have the indexer to improve the read and write performance. So by scaling out different components independently, that we are able to support tens of thousands of queries per second, hundreds of rows per second write throughput, and millions of tables and trillions of rows per table. And as I mentioned before, LanceDB is not just a vector database. We can connect to different existing open source tools to leverage this functionality. You can use Spark to fast generate your data to the Lance format. It basically transfer from Spark format to Arrow format and then to Lance format, eventually reside on your cloud storage. You can use DuckDB to do quick single node data analytics. You can use Presto to do distributed query. And you can use Ray and PyTorch to do training on top of the Lance dataset. And you can use the LanceDB, either is the open source embedded version or the distributed cloud offering, to do serving and search. Now I will hand to Beinan to share more about our Lance Presto connector.
Thank you, Lu. Thank you, Lu. Very impressive presentation. Yeah, I will continue. I will share some context about why we want to build the Lance connector. The thing is, I know the Lance is already offering some really good cloud solution, but sometimes probably you don't want to pay the money, or maybe you just don't want your data to be managed by other companies. For sure, you can try our open source solution, like Presto plus the LanceDB connector. So this graph will show how to connect Presto and Lance into your GenAI architecture. So I think for most company, they already have been there for a while. You already have the Hive data warehouse, and also maybe you have several petabytes data in your data lakes, like maybe Hoodie or Iceberg. So in this case, probably you may want to populate your embedding data or some whatever feature from your Hive data warehouse or data lakes into your LanceDB. So you can put Presto as something like an ingester to ingest your data into the LanceDB. And on the other side, you can make your GenAI infrastructure to generate, use some embedding model to make your query or whatever, to query the data in the data set. And also, you can also use Presto here, or maybe some other query engine, maybe more lightweight, to get the top K relevant context. You can have the context and do the model inference to construct your GenAI prompt, or maybe you can have a few examples just with the code you have. So here is the backend reason why we have the LanceDB connector. And just like other Presto connector, we have very similar architecture for Lance connector. So here, for each Presto worker, we have an embedded LanceDB. But this is not a separate service. It's just a library, because we already know the Lance is implemented in Rust. So here, we are using the Java GenAI to connect the Presto worker to Lance. So in this case, we don't have any actual service or process running there. We just use pure Java, and you don't really need anything like the catalog service, or you start other database service. You can just put your Lance file in the cloud storage, S3 or whatever, and Presto will try to get metadata from your Lance dataset. It's just a set of Lance files, and you can get the metadata of the Lance dataset, and then the Presto coordinator can split the task based on the fragment. I will talk to this one later, and it will generate the splits, and for each split, it will send to the worker, and the worker will, based on your query, to pass the Lance data and do some filtering, projection, whatever, and return the data to the Presto coordinator. I think this is the same thing for Hive. And this architecture will make the query to be more scalable, because if you have 200 workers, which means you can scan thousands or millions of Lance files from one query. And yeah, just as I mentioned, after we got the metadata from a data set, we will generate a split based on the fragment ID. So in the Lance data set, it's more like the Parquet file is partitions, or maybe we can say row group or somehow. They may have several or maybe millions of the fragment. For each fragment, they have a unique fragment ID. We will just use this one to make it a split for here, we also have the file path or something, and also the columns we want. We will pass this one into the workers. And on the worker side, because we already have the columns we need, so very similar to the packet parser here. Because it's also columnar-based data format, we don't really need everything. We based on the column we need, we push down the column and the predicate into the Lance, so Lance know, okay, we just need column A, column C, and then it won't touch the entire file. It can super speed up the scanning. And the other side, because the Lance is using Rust, and the Presto, if you know about Presto, internally we are using something called page. That's the data component in Presto. So we need a bridge between these two. And for the Lance, it can construct the data into Apache Arrow format. It's a pure memory format. So here, we're still using the Lance to construct the arrow, but we passed in a pointer. We are not doing something like the memory range copy from Lance to Presto. We passed in a pointer, and we are using it's called the Apache Arrow FFI, so it can make the bridge. In the Java side, we construct this memory structure, but without doing any data copy. This is the same memory passed through from the Lance to Presto. There's more technical detail here. If you like, you can check the code. Yes, I think the GenAI part should be in the LanceDB code repository. I think last year, Lu and we implemented this, I think 1 year ago. I think this is not 100% efficient or zero copy, because if we're talking about the page source, we still need some copy from the Apache Arrow, because we need to construct the page object in Java, the JVM's memory, because here is off heap. So I think in the future, if we can fully adopt the Prioritissimo and the vlogs for here, because the vlogs is also using the Apache Arrow compatible memory layout. So for here, we can achieve the true zero copy reading. Okay, here I will talk a little bit about the data consistency and we call the snapshot level isolation. Very similar to Iceberg or Hoodie. For each Lance data set, we have a version. So which means when we write something, because I think the majority use case on Presto side should be the write case rather than the read. So when we write something from Presto, maybe you join quite a few Hive table and Iceberg table. So here, you will split your data into maybe quite a few workers, maybe 4 workers or 2 workers, whatever, and the worker will write a new fragment into your data set. And after the Presto finish all the writing job, it will collect all the fragment ID we wrote from multiple workers. The code actually is already there. It's just the Presto basic mechanism. And when we finish the table writing, it will make a commit call. It will push all the fragment ID just in one time into the LanceDB dataset, which means if anything failed during the middle, you won't commit the fragment ID, which means the data you write but uncommitted won't be reachable by any other users. And on the read part, they just check the version. For maybe you already start a query from the old data, so it won't touch the new data. So in this case, we can have, we call it snapshot level isolation, which means the reader won't read the uncommitted data, and for the writer, they won't see each other. And if you start a read, you can make sure you will have the full view of the current version you are reading. Yeah, I think that's the almost everything I want to present today. But I can also share the future work. Some of you guys maybe already know we are trying to upgrade the Presto into Java 22, and after we upgrade to Java 22, we will use the Java foreign language interface instead of the GenAI, because currently the GenAI interface, the performance is okay, but I mean the read performance is okay, but if some upstream call from Rust to Java, the performance may be 100 or 200 times lower. So in this case, I want to try the foreign language interface instead of GenAI. And on the other side, we want to make the LanceDB connector as a prioritizable connector. Then we can fully connect to vlogs. We can use vlogs to support more functions and have a much better performance, as well as the zero copy reading. Yes, I think here is one page from Lou. If you want to join us, for sure you can join the Presto-DB Slack channel. But if you like, you can also join the Discord channel from Lance. And we have really warm and nice community there.